we want to start wrapping up this unit. So the unit consists of the simplifying fractions, the solving linear equations just with and without fractions, with inequalities, which, trust me, some of you I know, I can hear the rumblings. Some of you going, what, don't get it. It is so nice once you sort of get it in your head. It's easier than the fraction stuff. And then we're going to finish off with simultaneous equations, which are also very pleasant. I believe we have done the hardest bit with the fractions, and you will have time to go back over that stuff. All right? So I like to keep going back over and over. Those of you who have got beautiful working, once you come up and you're going to start doing your reviews, it's not a test at the moment. So if you go, oh, not quite sure, go back. Look at what you did in previous questions to assist you. All right? And I keep saying it to you, and I hope you don't get sick of it, but I know some of you are not into the habit of doing that in year 8 and year 9 because you didn't have to. The work was like, no worries. I've got this. I can do it. So now we want to start developing and making sure that we go back and we use our books and you're going, what is the theory here? So if we look at this one, we might at first panic and go, ugh. Look at those X's everywhere. However, what do you notice? We're looking at, remember we've got that technique now, can we times through by the lowest common multiple there? And if you look at the right-hand side and then the left-hand side, what do you notice? Oh, hang on.
Same denominators, but like you just have to times the X.
Yeah, exactly. So if we were multiplying, right, to subtract two fractions, we know we need to get the same denominator. And so you know that you were going to go, oh yeah, X times X plus 1 if I was looking at this side. And lo and behold, oh, that is the same as the right-hand side. Yes? So you've got options here. If you prefer, if you go, yep, I'm just going to do what I've always done, and I'm going to times my denominators together. And then what did we do? You cross multiply, right? So 2 times X plus 1 minus 3 times X. That equals the right-hand side. And then we go, well, look at that. That's just beautiful. The denominators are the same. And if left-hand side equals right-hand side and they're the same denominators, doesn't the top, the numerator, have to also equal each other? Right? So you're practicing that stuff that we did before. I'm writing an extra line just so you can see what is going on there. Okay, so the denominators have disappeared because they're the same. If that was an X plus 7, then no, we couldn't do that cancelling stuff. That's no good, and we'd groan because then we'd have to cross multiply. Yuck. So we can now expand, and would you agree that everybody, I'd like to think, could solve it from here? Yes? So that's the hard bit. Also, keeping in mind, if you had cooked this step here, if it had been a little bit of a disaster, I would still be marking your work from this point on, if I could read it. There's a reason I said that. If I could read it. So in a minute, when I'm quiet, you will make sure you can tick off, I'm happy with the fraction stuff and solving all linear type equations. And remember, you will have time to repeat that. You will then progress to exercise 5D, where we're dealing with inequalities. And again, you don't need to write this down at the moment. I will save this to Daymap. If you want to write it down, you sure can. I will save it to Daymap, but again, we're just making sure we understand. So inequalities, those are your greater than. Okay, I like to go big, small. You're reading from left to right. The big egg is greater than the little egg. Of course, you've got the less than, and if you've got the equal sign underneath, that's greater than or equal to. Does that mean anything special? Not really. So typical, they start off nice and small, just like we did with the equal sign. So I don't know if you remember year 9, you might have gone, let's start with 5x equals 10. 4, and then it built up to some of the fraction stuff that we've done today, correct? But how did we do this? Same. How do you get rid of a times 5? Divide 5. Well, none of that changes when you've got an inequality. Okay? 5 times x is greater than or equal to 10. What value of x could that be? Well, all we're saying is that we could have multiple values for x. Not just one. When it's 5x equals 10, one solution. 2. Now, we could have multiple. Oops, didn't mean to do that. So, on our number line here, we're saying x is greater than or equal to 2. That's what this means. It can be 2, but it could also be 2.1, 2.3, 2.555, 3, 4, 5, 6, 100. All of those values make this statement true. Would you agree? So as an example, if I took 3, so let's say 3's over here, that means it's that side of 2. Sub it into my equation. 5 3's are 15. Is that true? 15 is greater than or equal to 10? True. So that works. However, if I took, let's take x is 0. That's over here. Do you agree? So not in my solution domain. What's 5 times 0? Because again, I'm just subbing it back into this equation. 5 times 0 is 0. Now clearly 0 is not greater than or equal to 10, is it? So that's why that does not work. So that's all we're doing. Exactly the same as an equal sign, but now we can have multiple solutions. And if you multiply, so if you times or divide by a negative somewhere in your working, change the direction of the inequality. That's it. That's the hard bit. Everything else stays the same. And I think we can handle that. Well, I think we can. The other little bit to remember is just our notation. And I got to tell you, at Year 10 when you're doing this, they're saying sketch the solution. That's really the only time you have to do it. So maybe do it for 1 or 2 and then I'm over it. So as an example, 4x, notice, what's the difference between, apart from the numbers? Greater than, not greater than or equal to. Do the same thing. How do you get rid of a times 4? You divide 4, x is greater than 3. So the big difference is now it is a open circle, a round dot, because we're saying, oh, it can't actually be 3. Why? 4 3s are 12. Is 12 greater than 12? No. So isn't that common sense? So it's saying it could be 3.00001. 4 times that is going to be greater than 12. It won't be equal to. So look, the sketching, I'm not overly concerned. Does that calm some people's fears? It's not that bad. So, haven't calmed your fears. Watch. I think I will calm your fears. Here we go. Typical question. So, how are we going to solve this? And if you're getting worried with the inequalities, what would you have done if I had that? What would you do? What's the game plan? Oh, thought you were putting your hand up then. What's our game plan? Put all the x's onto one side, right? So pick a side. Let's go left. I'm glad you went left. So if I went left, I know we should have gone right, but we're going to go both, right? If I went left, how do I get rid of this 6x? I take 6x, so what's 2x? Take 6x. And while I'm here, I'm going to chuck the 8 on the other side. How do I get rid of a take 8? Add 8. We happy with that? So now we've got minus 4x is greater than or equal to 8. So nothing out of the ordinary. The only difference is instead of writing equals, you've written greater than or equals. Agreed? Okay. I hope this doesn't spook you. We're getting there. Now, for those of you, some of you went, I I didn't want to put the x on the left. I wanted to go to the right. Fair enough. Because how do you get rid of the 2x? You take, so we've still got the negative 8 here. We've got that's greater than or equal to 4x. Houston, we've got a slight difference here. Anyway, it's okay. We'll keep going. So, with this one, if I wanted to get x by itself, how do I get rid of the times 4? Divide 4, so it's negative 8 divided by 4 is greater than or equal to x. So we get minus 2 is greater than or equal to x. Now, what we talked about the other day, or just this morning, sorry, not the other day, that's greater, that's little, correct? So if I was to write this, is that okay? Now, would you say, oh, I've got some shaking. Okay, watching. Can you see that the little end is still pointing to the x here? Right? So if I have, let's not use negatives. That was a bad example. If I've got, what did we say this morning? 5 is greater than 6. Agreed? So if I'm reading that way, 5 is greater than 6. Is that right? No. So 15 is greater than 6, correct? If you read this way, is 6 less than 15? So remember, big, little. So when we're saying it's greater than, it's because we're reading from left to right. Big, little. Agreed? So notice the little bit's pointing to x. Is the little bit still pointing to x? It is. Look, little bit. Right? Negative, negative. These are exactly the same. Same. Oh. So, come back. How do I get rid of the times negative 4? Don't write anything at the moment. Now, if I just do this, 8 divided by negative 4, I end up with that. Is that the same? Where's the little bit pointing? It's not pointing at the x, is it? So this is the example. What did I just do to go from here? I divided by negative 4. So I have to change the sign. Right? Is that now the same? Yes. So that's the bit. Yes, look, there was a negative here, but can you agree with me that I did not divide by a negative? I divided by positive 4. So I did not have to switch the sign. And technically here, I have not switched the sign because the small point is still going towards my x. Here, I have switched the sign. Big point, little point. That's it. Everything else, same solving, same switching sides, but if you times or divide by a negative number, change the direction of the inequality. Yes. No. So I know that this is correct now. What's the deal? Most of them will write it like this. They'll always have the x on the left-hand side. Okay? It's the same as when you've been doing your solving with the equals, right? Is this the same? X equals 4, 4 equals x. Are they the same? Absolutely. Which one do we gravitate towards? X on the left-hand side. So that's probably nicer. But as long as, right, the little bit is pointing in the right direction, it's got to point at the right spot. Does that make sense? So what is it that you are going to be doing? Well, you've got time. I'm going to just chat to people now individually. You have got time to be doing the fraction stuff. Any questions that you are still unsure of, you ask me. You are. That's why I'm going to chat to you. I like to have a chat, not just go. And then you are working your way through. Do you want to spend a few minutes just starting this together? So those who said no, you are carrying on. I'm just going to take 5 minutes to get jiggy with these. All right? So ruling up today's date. I will save all those other notes if you really wanted them, but I don't think you need it. we're just going to get stuck in. Does anyone want a moment to write stuff down? Let's get started. Here we go. I repeat, you're doing your thing. Or you are doing it with moi. Yeah? You play nicely. Right, thanks. So if you're all good, we are carrying on. Sharp, shiny. So simple. How do I get A by itself? Get rid of the plus 4. Take 4. A is greater than 2. Whoa. What's the new bit? Show the solutions on separate number lines. Now get ready for this because this is tricky. We draw a line. We stick a 2. Right? And we go, it's greater than. So that means it's an open dot. Now if it's greater than 2, which way is the line going? Papa. Done. I mean, really. How nice was that? And you sort of go, it's not going to stay that nice. No. They get a little bit trickier. How do I get rid of the divide 2 times? But none of those hideous fractions that we were just working on. Very pleasant. Very pleasant. So, nothing to be afraid of here. Next one. How do I get rid of the times 3? Divide 3. Am I dividing by a negative? No. There is a negative here, but I'm not dividing by a negative. So, it's the sign stays in the same direction. Yeah? We draw our number line. We stick a negative 3 on there. Right? Your big decision. Is it a closed dot or is it an open dot? It's closed. This is nice work for a Friday. Uh-oh. Which way does the line go? It's less than -3. To the left. Less than. Can we? So, great question. Do we have to draw the line? Personally, it irritates me. And I think, yes, it's obvious. You should know it. So if you get to the point when you go, seriously, I've got this. You know when you have a closed, when you have an open, which way the arrow goes. You don't need to keep drawing them. How many from each? I want to say all. Not everybody got full marks for your test. You guys would be close to finishing. Okay, that's all right. I misjudged. My bad. I also thought I would have spoken to everybody this lesson by now. And it's been like 10. Not even. Okay, so trade quickly, but not too quick. Shh. So you just are silent doing your own work if you think that, I don't need to listen to this. If you haven't got up to it, then I think you should listen. So we want to get to x, right? The furthest thing away is the -2, so we get rid of that first. So it's 2x over 3. How do I get rid of take 2? Plus 2 becomes 6, right? And now it's simple. Get rid of a divide by 3 times 3. Get rid of a times 2, divide by 2. Do I have to change the inequality? Niet. Why? Because I did not divide or times by a negative anywhere. Did you listen to that one? No. So come on. So the -2 is the thing that's furthest away, right? X times 2 divided by 3, take 2. Last thing that happened to it is the take 2. That's the first thing that we undo. So get rid of a take 2, add 2. Now we're looking at this. We want to get x by itself. There's a divide by 3. Let's get rid of it. Opposite divide 3, times 3. Left with the times 2. How do we get rid of times 2? Divide 2. It's the same routine over and over again. With this one, remember, always have your eye on the x. What's the thing that's furthest away from the x? That 2, you look in front, it's a positive 2. How do I get rid of a positive 2? Negative 2. So we take it. What's minus 3? Take 2. Minus 5. If you know, some of you have talked to me already, I'm not really good with negatives. So you would know that you would double check. You'd think of it in your head and go, yes, minus 3, take 2. It's not minus 1. It's minus 5, but double check on your calculator. How do I get rid of this? Divide by 4. Times. Now, if this was minus x equals minus 20, what would you do with those negatives? Wouldn't you just cancel them? What you're technically doing is you're getting rid of that times negative 1 by dividing by negative 1. So that's what we do here. Watch my technique. Negative and a negative, so I'm dividing by that negative, so I cancel. Because I divided by negative, what do I have to do? Switch the sign. That's it. Done. Simples? Normally what I would do is I do this when we do graphs. All right? But it fits in nicely with what we're doing now. And I can see, look at the eyes. I can see, doubting me. God, trust me. Because again, it looks dodge. We do one little thing and you'll go, oh yeah, I can solve this. And it's practicing the work that we did earlier. So it's a bit of repeating, practicing our skills and revising some of our earlier work. So it's a good thing. All right. So one of the things you need to know is that each of these they're basically representing a straight line. And each one is a different straight line, and we could have something that looks like this. And so what you're going to find is this unique solution, one solution. But if I have 2 straight lines, will they always intersect once? What could happen? They could be parallel, and so that would then mean that there's no solution. They do not intersect at all. Is there any other situation that could happen? You can't see this at home, but I'm getting my 2 straight lines. Very friendly lines. On top of each other, that's right. So you could have one line on top of the other, and we call that coincident, and there are infinitely many solutions. Coincident. Now, again, you don't worry about worrying all that stuff down. This is more when we do the graphical stuff, but it's nice to just keep it all in mind. So, how do we find this unique solution? There are 2 methods, and it depends on the information that you've got. Today, we are just going to look at the method of substitution. And I know it's not English, but what does substitution mean? Pardon? Removing. Sub. What about, hello, Mr. Volleyball, broken leg. So if you were to sub with someone, what happens?
Swap.
Swap. Replace one with the other. And that's exactly what we're going to do here. So when we've got this, look at this. We've got y equals that. So what I'm going to do is I'm going to sub. Instead of the y here, I'm going to sub that in place of y. Sub it. Right? And I'm going to go, so 3x, sub. Hello. Watch this. If you don't watch this and you think, yes, I know what's happening, and you tune out, you're going to miss something in a minute. And if you're chatting while I'm doing this, 1, you're going to miss it, and 2, you're going to annoy me. And on a Friday, that's not a good thing. So 3x, instead of going take y, what are we saying y is? X plus 5. Now, sloppy jalopies in the class, we'll do this. Why is that sloppy? Right, you are taking all of this. Hello, my brackets. Or, as Smitty said, you're taking X and you're taking 5. I'm going to pop the brackets in because I'm a bracket kind of girl. Equals, I'm following along. It says equals, I put equals. What does it equal? 1. And now all you have to do is solve like you were doing before. So we go 3x. What's technically there's a minus 1 there. What's minus 1 times x? Minus x. Minus and a positive is a minus. So Smitty would have gone straight to this step. Yeah? What do we do now? Gather your like terms. That's right. 3x take x is 2x. Let's get rid of the take 5. Chuck it. And therefore, x is? And you think, well, that's awesome. Now, you're nearly done. But this is the catch. So 1 was the sub. The next was, not only do you need to find x, but you also need to find y. Now, you could sub it into either one. What's the obvious one to sub it into? The one that says y equals x plus 5. So x plus 5, 3 plus 5 is 8, y is 8. Right? In my day, to check, you'd also sub it in here. So 3 3s are 9, take y equals 1, put the y on the other side, bring the 1. Yes, you still get y is 8. So that's why it's a simultaneous solution. It works for both. You can get the solution on your calculator. Graphic. But we'll show you that next week. For now, we're going to do it nicely. Let's do one more. And if you're thinking, oh my God, I can't write this down. I've got a video for you. Now, so heading, simultaneous. Come on, heading in a column, simultaneous, and today's date. We're writing this now. So y equals x take 3. Wherever y appears down here, we're subbing. We're subbing. So we keep the 2x. We keep the plus. We've got the 3 times y. But what is y? Ollie, you're writing this down. What is y? X take 3. What comes next? Equals. Equals, it says 26. I put 26. And now, would you go, I can solve this? Because we keep the 2x, we expand. 3 3s are 9. That's right. Oh, no.
Yeah.
So hopefully we've gained a little bit of trust when I said, this is now actually not that bad. It's easier than the stuff for the fractions again. You go, oh, yeah, she's not lying. I'll be honest with you when things are going to get ugly. So 2x plus 3x, 5x. How do I get rid of a take 9 plus 9? Oh, look at that. So pleasant. 5 times what? Gives me 35. 7. X is 7. Before you go on to the next question, don't forget to find the y value as well. So 7 take 3. But do you know what? Who just said that? It's easy because he was actually just listening and paying attention. You were doing something else. No, you weren't. Now, guess what? We're going to be really tricky and try and trick you and make it harder. And instead of having y equals, oh, I'm going to have x equals. Anything change? No, you just sub the x where the x is. I mean, seriously. But this is a question that hurts kids' heads sometimes. Where'd it go? D. I'm bringing it back just... But Ollie, that's what I'm saying. If you had been paying attention instead of looking at your iPad.
I was focusing on my charge.
Yeah, that doesn't even make sense. I'll tell you the page in a minute. We're watching here. Shh. So, D. We just got into the hang of where the y was in here. We subbed it in and all of a sudden, no y. Well, guess what? Anyone want to have a guess? What would you do? You got y, you got y. It's the same. So doesn't it mean that these guys have to be the same? So it's just 2x, take 12 equals 13 minus 3x. Huzzah. Can you solve that? X is on one side, non-x is on the other. Huzzah. You will solve in a minute, and this is the last because now I'm going to stop. But look at x here. Instead of y equals, they've got x equals. So wherever x is here, we will sub that. So instead of 5 times x, what are we going to replace it with? What is x? Y plus 9. What happens next? Plus 2y equals 10. Well, now expand your brackets, gather your like terms, solve for y. Don't forget, once you've found y, get your x value. Does that make sense? It is. Say that again.
It is surprisingly simple.
I agree. But again, it comes down to practice. If that went too fast for people right at the end, on the YouTubey thing, Macca's Maths, I've actually gone through most of the questions because this is the time, I think, last year when we were doing online learning. So all of the questions actually go through. So if you get stuck, you could have a look. Do I need to show you? No. Good. Thank you. So it's there. All right.